Okay, crew. Good morning, everyone. Thank you for coming today. I really appreciate you all for attending today. We have a lot to share and cover, so we really should begin. Before going to start the meeting, I would like to share some things about 𝗪𝗯𝗹𝗃 and its team. 𝗪𝗯𝗹𝗃 craves students for industry, making them experience an eager journey and lasting desire for learning. We are a team of skilled people striving for a better student and working professionals. Our objective is to introduce student community to industry experience and learning, to enhance the skill list and opportunities for deserved civil graduates. Coming to the 𝗪𝗯𝗹𝗃 CEO, Mr. 𝗪𝗏𝗏 Reddy sir is a CEO and founder of 𝗪𝗯𝗹𝗃. He is currently working as a structural engineer in MNC company in Vizag, dealing with US projects. He worked as an executive engineer for G plus 15-story high-rise buildings in Vizag. He also worked as RCC design and details engineer for central, state, and for several government and private projects in Vizag. Sir also worked as steel designing engineer in Pune, and now he governs and generous admit to provide all these webinars. And now this webinar is for free and about Cable Strait Bridge. And coming to his technical skills, he's pro at several architectural and civil engineering, AutoCAD, Revit, ETAP, Statro, TNX Towers, and many more. Coming to your for show, Mr. Vikram Singh sir, Senior Bridge Design Engineer at L&T, MTech Structural Engineer, IIT Kharagpur, qualified as ESE Prelims 2019 and GATE Air 743 rank 2018. Welcome to the webinar, sir.
Thank you very much for your kind introduction. Thank you, ma'am. Shall I start? Hello.
Welcome, sir.
Shall I start now?
Yes, sir.
Okay. So, good morning, all of you. Thank you very much for joining this session. This is a Sunday, and in the morning, 11 a.m., you are here, and it shows how eager you are and willing to learn a lot about the civil engineering. Although we are not a complete civil engineering as of now for this 1 and 1.5 hour, but today you are going to learn a very interesting topic, that is Cable Strait Bridge. I'm sorry I cannot tell you everything about this bridge as of now in the single moment, but today I will try to tell you why do we need this Cable Strait Bridge. Just a request to all of you, if you lag behind any kind of video, audio, or if you think I'm speaking too fast, please inform me, not in terms of chat, but in terms of oral, because I would not be able to see your chat during the presentation. So yeah, thank you all of you for joining the session. So I request to all, please do not turn on your video, but I will try to turn myself so that, but if you think that my video is creating some issue in your presentation, means while watching the presentation, please inform, I will close it off, okay? So now I will share my screen. Someone just please confirm that it is visible and it is visible to all of you. Someone please confirm, is it visible?
Yes, sir, it is visible.
Okay, thank you.
Yes, it is visible.
So today's webinar about this, actually we have a series of bridge course.
Sir, please unmute yourself.
Sir, you are not audible.
I'm sorry, by mistake I closed it off. Now am I audible?
Yes, sir. Yes, sir.
Okay. So I'll share my screen again. Please confirm it is visible to all of you. If anyone does not see my screen, either please try to refresh your browser or tell me again if you don't get it successful. Is it visible to all of you? Someone please confirm.
Yes, sir. It's visible.
Okay.
Yes.
So today we have this topic open webinar. Just give me, hold on please. I will turn my video on. My video is visible to all of you?
Yes, sir.
Okay. So if there is any kind of concern behind this, please inform. And I will just start. Yes, yeah. Today's topic is named Open Webinar. Actually, this series we have it is on 𝗕𝗏 bridge, but this topic or webinar is termed as Open Webinar, just to tell you that we are not going to discuss anything specific about this 𝗕𝗏 bridge today. Although we are going to discuss some of the factors and facts, but this open webinar itself means that you can come here and ask all your queries what you have. In terms of, see, if you are a student, then you have a lot of questions about industry. If you are a business design engineer, then most of you, I think, would be in normal business design. If I say in Hindi, there is a line I say that about myself, I construct, or in Hindi, if I say, हम ब्रिज बनाते हैं, पुल बनाते हैं, पुलिया नहीं. So please don't mind if it hurts to any one of you. That in this course or in the webinar, we are going to learn how do we construct this long span bridges, not those 5, 10 or 15 meter span bridges. Those are bridge which I say, if someone has an understanding of 5, 6 months or more, approx 1 year, someone can design those bridges. But believe me, if you come to a 𝗕𝗏 bridge, it will take a long time. And if I say how much I invested, you can count at least 8 by 500 or 600 days. I have given this much for my learning itself, not in the industry. So yeah, it will take a lot of time to understand this bridge. But today we are going to learn that why do we need this 𝗕𝗏 bridge. So I will start my presentation. It is just a 15-20 minutes. Then we will have the Q&A directly. Okay. So yeah. So this is the content for now. Just 6 slides. Like what is multi-deck system in bridge construction, what is double deck, what is 𝗕𝗏 bridge components, and why do we need it. That's it. We are not going to discuss a lot of today. So yeah, there are some rules for this session. But if you have any questions in any of the slides, please note down the slide number so that you can ask at the last. See, if you ask in the mid, the flow will be disturbed. And maybe the questions you are asking, the next person may not be interested. So we don't want to waste their time. So please note down the slide number and we will clarify them at the last. Next is please sit in a mild disturbed or very silent zone, because if you want to understand the concept which is very new and not for only bridge designers or who don't know what is bridge, but all of you, even if you're designing a bridge, this concept will be very new for you, what I'm going to tell you now. And if you have any queries about this course or webinar, that will be clarified at the end. One thing I would like to request to all of you that please listen first. If you are here just to watch the lines, what is written in the presentation, believe me, it is Maybe most of it is written in the textbook, and if you have studied the lines only and understand the concept, then you were not here today. And sorry, this point is not for today. Don't turn your cameras on as of now. You keep it off. You can turn on if you want so that I can see you, but I don't request or want you to on, but miss, I will keep my camera on. See. So there is a multi-deck system in the construction of bridge. Okay. Most of you may say that this kind of system is not available in India, then why we are watching this slide? The problem is India is not a developed country. We are still in the developing phase. This is a 4-level deck system, or you see the ground plus 3-story, and it is not available in India, and just because of its economy. But you would like to know, or you will be happy to know that there is a double deck system or ground plus 2 deck system in the Nagpur metro. This Nagpur metro is, I think it is still under construction only. So it is like a normal metro system what we have. So normal metro system is 1 deck ground plus 1 deck only. But here what we have, the ground plus 1 deck. On this first deck there will be a vehicle movement, and on the second deck there will be a metro movement. I have not shown this figure, the real figure here, the movement of metro and vehicles, because that was a hypothetical image. This bridge is still under construction and there is no movement of vehicle till now. But one thing I would like to tell you here, you see the presentation that there is a construction joint here, there is a construction joint here. Someone can please tell me what kind of bridge it is? Simply supported or cantilever or continuous? Someone please tell me what kind of bridge is you think?
Simply supported.
Simply supported. Okay. So just a random guess, I'm not asking you the exact value. What may be the approx distance of these 2 piers, center to center line? Maybe approx distance, I'm not exact value.
$20 meter approx.
50 or 20?
20
meters.
Okay, 20 meter. Okay. So see, maybe it is 15 meter or maximum 25 meter, not more than that. It will be approx 20 meters only. It's a simply supported span. This maximum bending moment in a simply supported span is, please don't mind it is below or up the profile. It is just what I want to show is a maximum bending moment at the support. If the maximum bending moment is at this support, then the biggest section you need is at the mid. And see, the one thing I will say here, I'm drawing this same profile at the top. If I draw this as a cantilever only, then what will happen? The maximum bending moment will be here and the supports, and the minimum section will be required at this place. What is the benefit of this section? Means constructing the cantilevers is, if the maximum bending moment is here, then you need a bigger section here and a small section here. And one more thing you would like to know, that if the section is bigger here, then it will again increase the bending moment or the dead load bending moment. Since we are making the bigger section in case of cantilever at the support and a smaller section at the mid, you are reducing the bending moment itself. And if you do know that most of the load in the bridge, if I say in the normal bridges, it is approx 45%, and in case of long span bridges, it is about 65% of the total load lies because of the dead load of the deck itself, or if I say not the deck, itself the weight of the structure itself, the bridge. Bridge may include the upper pylon, lower pylon, cable, deck itself, etc. But if you are reducing the bending moment, you can save the economy, you can save your money. So that's the benefit, one of the benefit of constructing the cantilevers. That is the only meaning of showing this presentation here, is this photo here. That's why I did not use this hypothetical image of running the metro and vehicles there. Just I wanted to figure out here that in India, we have this ground plus first story of vehicle movement like auto, truck, rickshaw. And now second floor, there will be a metro movement. Yeah. So let's discuss few things about this cable-stayed bridge. In a cable-stayed bridge, the pylons connect to the deck with the help of anchoring cable. See, this upper, okay, I would like to state one terminology here. This is called upper pylon. This lower column is called lower pylon. Is in the industry we call it the pylon. These are the. I'm sorry, I am not a drawing professional, so please don't mind my writing and text. And this is my deck. In a cable-stayed bridge, the pylons connect to the deck with the help of anchoring cable, and the strength of this anchoring cable, if I say gross ultimate tensile strength of these cables is 1860 MPa. You understand the strength of this cable? It is 1860 MPa. Okay, I would like to tell you just small information here that the least is in general cable what we use is 15.2 mm diameter. So if I find out its area, it is 5/4 into 1860. Someone can please tell me what is the value here? Actually, I teach in the manner of discussion actually. So please don't sit idle here. Just tell me what is the value. Anyone? Yes? Anyone can tell me, or I have to calculate for myself?
The area of pillar.
No, see, this is the diameter of a cable which is used in this anchoring cable. So this is d square, this is pi/4 d square, and this is ultimate strength. So this is millimeter square, and this is my Newton per millimeter square. So tell me the value what you are obtaining here.
337.51.
337.51 kilonewton, right? Kilonewton. Okay, and if I change it to tons, this is 33.7 ton, right? Do you understand the strength of cable? A cable with your this much size only, maybe this much size or this much bigger cable can pick it up approx 34 tons of the weight. This kind of cables are used in this anchoring of the cables. Okay, so don't underestimate the power of a high strength cable. Okay, so multiple available shape of deck and pylon structure with respect to surrounding environment to give aesthetic look to the cable-stayed bridge, which is most often also as used as a tourism place. Okay, so you would have listened about this tourism place of recently 𝗪𝗏 𝗪𝗏𝗪𝗏 𝗪𝗏𝗕, or this is in Narmada River, which our Prime Minister Narendra Modi inaugurated, and it is built now. These places are used for the tourism also. And see this span. This span is more than 200 meter. I don't know the exact value, but it is more than 200 meter. And these places are not general construction. So these are also used for a tourism place. And if you see, this watercolor is sea blue. I don't know the exact term, but I'm writing this as sea blue. The color of the structure is also made in the same fashion so that it looks aesthetic to the surrounding environment. Although it includes so many properties, I can tell you a lot, but there are very less number of cable-stayed bridges in India. This is because the limitation of material strength and lack of design methodology available in past. But the future is emerging with enormous cable-stayed bridge and extra bridge. although there are two terms, cable-stayed bridge and extra-dose bridge, but as of now, you can consider that both are approximately similar. The only difference is that the upper pylon of the extra-dose bridge is smaller and the cable-stayed bridge is longer. As of now, this is the only difference for you, but there are certain more differences which we can discuss in the next videos. Okay. So, in sketch, if I tell you this is my cable-stayed bridge, this is typical sketch, and there is a pylon, or this is called upper pylon or tower. This is lower pylon or column. This is my cable stays. These cables are called cable stays. This is my at the end there is cable anchorage, and this is my deck, and entirely it is called substructure as supporting system. So these cables are under tension as represented here, and deck is under compression. I will tell you one more fact about this in the next slide. If cable strays are arranged on a single plane, different shapes of pylon towers such as single column, A-type, reverse by type, diamond shape, there are some shapes I will tell you. So yeah, these are the different kind of shapes which are used for the construction of the cable-stayed bridges. See, this is H shape, this is A shape, this is reverse Y, and this is my diamond. Okay, so the different shapes of a cable-stayed bridges. Okay, you may say that this kind of shapes you may also make in small bridges. Okay, just tell me, if you are constructing a pier for a smaller height, where would you introduce your shapes there? It's already a small bridge. Okay, and in the small bridge, if you are constructing a small bridge, then obviously one of the prominent factor there is economy. A small bridge is never a requirement if you have the economy. Okay, so that is a major concern during the construction of a long span bridge. These long span bridges, if you have seen, or in this presentation also, most of them are constructed under water carrying structures. If you have the ground, like in the cities, like we construct the metros, those piers are constructed at the distance of 15, 20, 25 meters generally, because you have the land available there. But if you are constructing a bridge inside the water carrying channel, you know that you cannot dig out at every place and construct a pylon 1, pylon 2, pylon 3. You cannot do this, right? So you can, what you do, that you will construct a pier here, a pier here. It is not just a pier and pier here. It is just a pylon, bigger one. So bigger one here, and then you will connect all of them by cantilevers. See, small bridges you can make by simply support directly. But the long span bridges are constructed in the fashion of cantilever from this support, cantilever from this support, and then it is made a joint. If you make it a joint, you can see that it is now a continuous structure. Okay. What we do in the construction of long span bridges or cable-stayed bridges, we construct them as cantilever, connect them at the mid, and make the structure continuous. Okay. And all of you know that bending moments in a continuous structure, although may not be exactly, but the moment redistribution takes place. So if you make the envelope, that if you add algebraically the value of negative bending moment and positive bending moment, the same may remain same. Obviously, it should remain same. Either it is continuous structure, simply support, or cantilever, but the values of suppose it is simply supported, then at the support it is value 0, and most of bending moment is at the mid. So you have to design a section at the mid, and you cannot just make a tapered section. You have to give it uniform for the strategicity. But if you have continuous structure, the bending moment values will reduce. Although reinforcement requirement may be at the mid somewhere, at the top somewhere, but entire section will reduce. So making such a small section will be economical for all of you. Okay. So let's come to the main point of today. Why cable-stayed bridges? Okay, we have a lot of kind of bridges, although I have not shown all of them here, but I will tell you here. We have the beam bridge, arch bridge, truss, or if I say cable-stayed, extradose and suspension. Someone may ask that why we are not going for suspension bridge. Okay, see, we move towards the cable stayed bridge from beam bridge, arch bridge, truss bridge because of the economy. We cannot construct 15-meter distance pier in a sea or river, so we move forward towards the cable stayed bridge. The suspension cable is mostly steel only, except the tower and this deck. Actually, the deck of this suspension bridge is thinner. So a lot of steel is required for the construction of suspension bridge, although the tower distances may be increased, but a lot of cost is required for the construction of suspension bridge. That's why they are not most prominent in India. But then why we are studying this cable stayed bridge, that is a question. See, if you know about the economy of India or about other foreign countries, that India is lagging behind approximately 15 to 30 meters behind these developed countries. So what is already constructed there in India is approximately in terms of construction. Please don't go in terms of ISRO. Okay, ISRO is doing a great job. They are moving even forward towards the China and America. But in terms of construction, and the construction in India is lagging behind approximately 20 years. So what they have already done is now started in India. Okay, so already they have constructed these kind of bridges 40-50 years, and in India, if you would have seen, we are constructing a lot of extra dose bridges now. Extra dose means it's a lesser span and lesser tower height bridge with respect to cable stayed bridge. But in the next 4 or 5 years, the cable bridge will be the emerging field. And then why we are studying this as of now, not that time. Because if you don't anticipate a learning before it is emerging, you won't succeed. I don't remember exactly year, but Flipkart emerged in 2011, I think. After that, how many online sale industries have emerged? Do you remember? But even still, Flipkart is number one, at least in India, not in foreign. Foreign it is Amazon. But in India, the prominent or prime delivery site is Flipkart. Because if you anticipate the future before it is happening, you will succeed the more. Anyway, that's not a topic. I will tell you the why do we need the cable stayed bridge. See, this is my anchoring cable. This is anchoring cable. Just tell me one thing, okay? This is an interesting topic. Just tell me a few things and you will get it much more, okay? This is my deck. This is deck. A vehicle is standing here. Can someone tell? It is either moving this direction does not matter. But suppose it is, when it was at this place, this deck will bend downward. Can someone tell me what kind of force will appear in this cable? Anyone? This cable will undergo tension or compression?
Tension force.
Okay. So I'm drawing a free-body diagram at this place. Just see this thing. This is my tension. And now, this is my deck. And this is a pole. Okay. If this is under tension, means suppose this is my anchor and I'm pulling this cable through the hand at this side. Okay. Just tell me what kind of force will be there in the deck. This is my deck. What kind of force will be there in this deck if I'm pulling the upper cable or anchoring cable in the inclined manner? It is tension or compression? Yes?
Tension, sir.
If I'm pulling this thing from here, so what kind of force will introduce in this deck? Tension.
Deck section ma top compression and bottom tension.
No, bottom tension and compression is caused because of, suppose I'm drawing right side. If this is supported and you have a load here, then obviously the top is going under compression and it is going under tension. I'm not talking about the deck. I'm just talking if this is a linear element. You don't know whether it is steel, concrete, anything. If I'm pulling this cable here, see, this is my compression. Okay?
Compression.
Now see the thing. When the live load is here, the cable undergo tension. Because of this tension, the deck is undergoing the compression. And this deck is made up of concrete. And we all know already that my concrete is strong in compression, not in tension. So what happens when your live load comes on the deck? My deck is undergoing more and more compression only. And concrete is strong in compression. That's why we are more utilizing the strength of the concrete itself. The deck is not going under tension now. It is going under compression only. And it is going under compression at the time when live load is there. See the thing. The deck is not, although there is under compression only, but suppose it is under the compression of 10 MPa, when there is no vehicle, it is dead load at anchoring cable. But as soon as there is a vehicle, there is a tension in the cable, the deck is undergoing more and more compression only. Means that compression in the deck, which was 10 MPa earlier, now it is increasing to about 15 MPa in the deck. You are utilizing the strength of the concrete itself. Do you understand why do we need this kind of cable forces and the cable in the bridge? This cable is itself giving us the utilization of the concrete. One thing. That is about the anchoring cable. Now, just one thing I will tell you here, that suppose this is my deck and you have introduced some pre-stress. What do pre-stress do? It utilizes the strength of concrete in compression by not allowing the tension in the concrete. The anchoring cable is again doing the same thing. But why we are not doing the pre-stressing more? Instead, we are applying the anchoring cable. The problem is, this pre-stress cable will have an eccentricity for movement equal to the depth of the section. But if you need more and more eccentricity for carrying the forces, what you do, you apply the external cable, which goes up to the pylon and then go back to the next deck. So what happens when the vehicle, suppose this is my support, this column, one vehicle is here, it deflect down, the deck will deflect downward, the cable force will transmit to the pylon will also deform this side, although not that much. But as soon as it deflects to the left, all of the cables on the right side will again undergo tension only. What is happening? The concrete on the other deck is undergoing the compression again. Okay? So the strength of the structure is increasing more and more as the vehicle is on the deck itself. That is a main advantage of constructing this kind of cable steel bridge. I think this would be the landing for today itself. So yeah, thank you very much. We have given, I have taken 30 minutes time. So that's all from my side. I hope you would have written the slide number if you wish to ask any queries. And this is the time for your Q&A. Means I do not wish to add a lot of discussion or content in this presentation because this is first. And I want all of you to understand my theory and how do I teach and whether you should join the next session or not. Okay. So today, now we are going to discuss about this Q&A. So please, thank you very much for all of you. Now I urge to all of you, please ask your questions. Thank you.
Yes, sir. Thank you so much for your knowledge you shared till now. We are extremely happy for the knowledge. Yeah, attendees, it's last 5 minutes for us. If you have any kind of doubts or queries, we can reach out, sir, right now. We'll wait for 5 more minutes. And then we'll wind it up the meeting.
You can ask any kind of questions. It is not limited to the presentations only. See, this presentation was primarily kept for asking the questions. I just added few of the things so that you understand what we are going to ask in the question section.
So sorry to interrupt you. Just a kind of announcement. So attendees, please fill the form. Please give us your valuable feedback to us. We are flexible to your needs.
See, I'm watching some of the questions in the chat. Please ask orally, because I'm using a laptop display to for the
Hi sir,
presentation.
can I ask you a question?
Yeah, please.
Yeah, thank you so much, sir, for your great insight on cable truss bridge. First of all, great learning session. I just
Thank you.
want to know how effective is this cable truss, because it has to be there will be some creep in the, or some stresses will be induced over the time. So
Yeah.
how is going to be so much effective? Number one. And second question is as a cost effective, how it is as compared to pre-stressed or some other steel truss bridges, how it is which one is more cost effective? Can you please elaborate on these two questions, sir?
Yeah. So let's start from your first question, that is creep and shrinkage, right?
Right, sir.
So I will share again. Is it visible?
Yes, sir.
Okay. So your first question is about the creep. Sorry, I'll change the pen. First question is about the creep and shrinkage. Okay. So suppose I'm drawing a cable bridge here. It is a small typical cable bridge only, and please don't mind that why I have not connected here. It is just a representation for now. So your first question is what about the creep and shrinkage? The cable stayed bridges are generally constructed when the span is more than 200 or 250 meters. So if it is such a long span bridge, so what we do when there is a place for this expansion joint, we keep a gap in terms of meter, not in terms of millimeter. So if there is shrinkage, this bridge will shrink this side or expand this side. Expansion or contraction in terms of, I'm saying, you anticipate how much creep and shrinkage may occur in the construction of this bridge. Accordingly, you have to keep your expansion and contraction joint in the bridge accordingly. And one thing, if you remember, I just discussed that time, actually not now. This is my cantilever bridge. So obviously there is a gap and we connect both of them. What we do not connect them directly. What we do, this is my deck on the left, this is my deck on the right. I will keep a hinge beam here, which is connected through the rollers here. So whatever kind of creep and shrinkage you are talking about, that is accommodated in terms of joint here. You understand? So if there is creep or shrinkage, where shrinkage is obviously contracting the structure and creep is increasing the structure. All of the factors are already contracted or anticipated during the designing, how much creep and shrinkage may affect there. And accordingly, your hinge beam segment, which lies in terms of 2 or 3 meters, that will be designed. So this is about your first question, creep and shrinkage. One thing is here, and second thing is, even after constructing this hinge segment, if your contraction or expansion is not contracted, then after suppose okay, this is not my razors. Yeah. Suppose this is my 3 pylon system here. Okay. So what will happen after constructing these 3 pylons? Although there is a gap for the hinge beam, but I will leave approx 1 meter here to accommodate what kind of expansion or contraction cannot be accommodated in between the 2 or 3 pylons. So this section is designed separately. Okay. So this is about your pre-penciling case. And please, can you please repeat your next question?
Sir, and my next question was regarding the cost, like how
Okay.
cost effective it is, because as you said that it's a high tensile cable and all this. So what is the cost
Okay.
difference between a normal truss or normal steel type of bridge or any other structure or suspension bridge as compared to this cable truss bridge? Like how economical it is as cost wise? Is there any like cost, say for example 20% or 30% as compared to other bridges?
So this is the type or the name of the bridges I have written there already in the slide. I'm writing them again. Just understand the one thing. If I'm taking, suppose bridge length is 5 km. For example, I don't mind for this. What I'm trying to explain, if your span is suppose 15, 20 or 25 meter, then you will construct your beam bridge. You will not go for any other kind of bridge. Like in metro, what happens? We construct the simply supported bridges, although they are pre-stressed box cutter, but they are simply supported as a support. In the truss, we go for high distance. It lies in the range of 40-50 meters. Arch is also lies in the range of same. Means approximately they when you have to construct span in this range, then we go for designing of both. We design both and check which is causing the economy. Okay. Although there may be some difference you may read in the textbook, but in general, when you have to construct this much 40-50 meter span, then you go for designing both and then see which one is causing the economy. This extra those bridges are constructed when there is a span of 80 to suppose approx 180 to 200 meter. Cable stayed bridges are constructed when there is a, and the suspension bridges are constructed when there is, I suppose I'm writing in terms of this. So it is not about the cost or economy how you are going to manipulate. It is about how much distant you can construct your piers. If your main span can be constructed for this much length, you will construct beam bridge. You will not go for cable stayed bridge because cable stayed bridge will need a lot of reinforcement, pre-stress and anchoring cable. The cost of this cable is very huge. But just let me give one example here. This is my water carrying channel and its width is 10 kilometers, suppose 10 kilometers. Now, if I construct a beam bridge, then tell me how much number of PS you have to construct? Approx. But if you construct a cable stayed bridge, I am taking 400 meter as an approx. So this 10,000 by 400 will give me, can someone tell me the value? Okay, 25. So instead of 400 pier, you can dig out only 25 piers and complete your bridge. Do you understand how we are determining which kind of bridge we are going to construct? This is based on the topography, economy, all of the factors. Since you cannot construct a beam bridge or truss bridge or arch bridge here, because it is a flowing water canal, this water will not stop here. They will allow here that you construct any kind of bridge. You construct a beam bridge. No, water is flowing 24/7 by 365. It is not going to stop for you that you construct a bridge here. In that case, you have to decide that you go for suspension bridge or cable bridge or maybe extra dose bridge, but you cannot go for sure beam bridge, truss bridge, and arch bridge. So you have to spend a lot. You have to spend so that you can construct a bridge. It is not dependent on the cost itself. It is dependent on the geography where you are going to construct. I hope this answered your question. If
yes,
not,
sir, thank you so much for elaborating with such a great example. Really, now it's clear to me because I have seen a few of the Chinese bridge, which was made with RCC for a long span also. That was having like intermediate pier in between. I think this is of the first kind that was made in Japan. So that's why this question came to my mind. I hope you might have seen that bridge, what a bridge I'm talking about.
Yeah, I understand. I have studied a lot of them.
So that also I have studied. Lastly, I would not disturb much, sir. Say for example, some cables goes after say a few years, some cables get damaged. So do we consider that margin in our design? I mean,
Yeah.
say for example, 20% of the cable goes
Yeah,
wrong.
Understand.
Yeah.
So what we do, the ultimate strength of cable is 1860 MPa. Okay. What we do, we divide this with a factor of 1.15, multiply with a factor of 0.87, and the value. Can you please tell me the value now? Yes.
1407.13.
1.07 approx. I'm not considering a lot of. This is the strength of the cable for the design, but we still do not design for that. What we do, we apply a factor again 0.9, and this is I think 1265 MPa approx. We design for this cable stress only. So what will happen? I'm sorry. Sorry for that. What will happen if I design this cable only for this much and I apply the 10 cables? Even if one cable fracture, the other cable will reach to the design strength, not to the ultimate. So this will not fracture itself. Okay. Yes, we counteract, or we already anticipate that one cable may fracture at some instant of time. So we counteract that or anticipate that already in the design.
Thank you, sir. Thank you so much.
Thank you.
Yeah, thank you so much, sir, for your great explanation about our doubts. And thank you, attendees, for your active participation.
If there is any other question, please ask. Please, I can wait for a few minutes, but please ask the questions if you have. If you don't have, then we will wrap up the question.
Sir, deck is only in compression, so we provide only minimum steel in deck or any other design for deck.
Okay. So in a cable steel bridge, what happens? We do not apply the cables directly. What happens, as I told here, okay, I had forget to write one more bridge. In between this, after these three and before constructing these three, there is one more bridge that is called cantilever bridge. Cantilever pre-stress bridge. We construct this extra dose cable stayed suspension bridge only and only if your pre-stress concrete is unable to carry the loads. And applying the upper inclined cable does not mean that you have to exclude pre-stress. Pre-stress is still there because when the load is there, the deck is undergoing compression because of that load component only. But when there is dead load only, there is no cable tension and compression. At that time, the deck will undergo bottom tension. For that, we have to introduce a pre-stress to bring it under compression only. So pre-stress and cable both are present there, even in a cable straight extra dose suspension base also. So it is not like that if you apply your anchoring cable, then you can exclude pre-stress. No, you have to apply that also. Is that answer your question?
Yes, sir. Thank you.
Yes, sir. Thank you, sir. Attendees, please find the feedback form in the chat box. We'll wait for 5 more minutes for your doubts.
Sir, can I ask a few more questions, sir?
Yeah.
Regarding this course, like, and what you will be covering in this course, like in the entire session, can you elaborate on that, sir?
Okay. So just give me 1 minute. I will find it out. Okay, before that, I can tell you one thing that it is just a webinar for, I think, 1 hour or half an hour. But we are going to discuss a workshop also that is a 1.5 hours per day for 3 days. And this will be, I think, on the upcoming week. So if you wish, you can join that. Yes, yes.
Sure, sir. Thank you so much.
Just give me 1 minute. I will tell you the content also.
Yes, sir. Please.
Okay, this is not the content. Syllabus. Yeah. So what we are going to discuss in the course we have, that is first, means in the last session we had a class about the introduction to structural dynamics, but this time we will not have this because as much dynamics we need, I will discuss during the lecture itself. But what we discuss in the class is what are the kind of load, how do we apply them, how do we calculate them manually, and how do we use them in the 𝗓𝗏s. And the software is 𝗓𝗏s, which we are going to discuss in the course. And this modeling will go up for 3 hours. Each class is conducted for 2 to 2.5 hours. So modeling is done for 3 classes, so approx 7 hours. Then we are going to discuss about this upper pylon and lower pylon design, which will take approx 2 classes. Then we are going to discuss about the earthquake analysis, which is like pushover analysis, hinge properties, confinement properties, and how do we calculate the deflection, and how do we verify that our structure can undergo such a deflection or not. That is verification. And then we go for this deck design. If this is a deck, my deck, I'm showing this deck as in this format. So we are going to show for the design whether this vehicle, if it is traveling in the longer direction of the bridge, whether this bridge is sufficient strength or not. And if the vehicle is on this edge of this edge, this bridge will twist or not. We have to design all of them. And then there are some new concept, which is one of the new concept was plastic hinge formation. Second new concept is strut and tie model, which I don't think anyone know. I have learned this after undergoing 5-6 months of understanding. I have a lot of content for this. Then we are going for this basic well foundation design. It is just a basic, not a lot, because this foundation design is primarily governed by the geotechnical engineering. Although we are going to discuss few of the things which are structural engineering. So this is about the basic only, because we cannot go a lot to discuss about the well, which is geotechnical. Okay, but still we are going to discuss it for more than 2 or 2.5 hours. Then we are going to discuss about suppose if I can write here. No, I cannot write. So suppose this is my well. At the bottom there is a triangular geometry, and below this triangular geometry, okay, I will show you one thing here. Please rely with me. Just a minute. Okay. So I hope you can see my presentation now.
Yes, sir.
Okay. So this is entirely a well foundation, and we are going to have one class for this well cap design, 1 or 1.5 class for 1 to 1.5 classes for this well staining design. Then we are going to have one class for this well curve, well cutting edge, and bottom plug design. So this well foundation is itself covered in approx 4 lecture, which cover approx 2 to 2.5 hours. So approximately 9 to 10 hours. So this is as of now, but for the next session, actually, I am modifying this content. So this course will include approx 30 hours of lectures. I hope I replied.
Yes, sir. Will it be like a live demo session like this, or it will be like a self-based learning?
Yeah, it is live session only. See,
okay, great.
I will teach you live. If you have any query or like a classroom only, as I am teaching you right now, the session will be in the same format, and you will be given the access also for the recorded sessions.
Means it will be live just like now, right?
Yeah.
Oh, that's great. I was looking for the same, sir, because so that it was very interactive today. Like, I had discussion with, few days back, and I was waiting for this live session. Thank you so much, sir.
You can see the content also. I hope you would like it, because
I have gone through, sir, I have gone through the contents. I was only having the doubt whether, it's going to be live or to have more elaboration. You have elaborated very well, sir.
Yeah. Thank you.
I'm looking forward for this course, sir. Thank you so much.
Thank you. Any more questions?
Attendees, any more doubts, please ask Vikram sir. And Vikram sir, thank you very much for your extreme efforts towards this.
Okay, so just give me 1 minute. I will share 1 minute only. Just give me 1 minute, okay? Please participants, just stay here for 2 minutes only because I need to search that first. I will just take 1 minute of sharing and 2 minutes of time. Where is it? Invisible is, sorry, just give me 1 minute.
Attendees, in this short time, please kindly share your feedback with us. You can find the feedback form in the chat box.
Okay, I'm sharing my screen again. Just please confirm it is visible or not. And it's just a 1 or 1.5 minute video. My screen is visible?
Yes, sir.
Okay. So this is not my video. It is a YouTube video. I just want to show you that. Just that's it.
You know, for those of us that don't know me, know that I ran a ballet company for 15 years. And I would deal with the public. And they know nothing about what we do as structural engineers. When I would tell them, we create computer models of bridges and buildings in the computer memory, we shake them with earthquakes, blow wind on them. And the software tells us which portions of the structure are gonna break, and so that you can fix it before it's even built. I mean, they look at you. Man, are you some kind of a genius or what? But you see, that's what we do. They don't know that. This is the kind of education that we need out there. The beauty about structural engineering is that you make life better for all of humanity on a daily basis. That's what you do. You're in the business of actually saving lives. I mean, people become heroes by saving one life. You are saving lives every time the wind blows. But they don't know that out there. The Salesforce Tower, the biggest tower in the Western Hemisphere, performance-based design. The only reason that building will actually stand in San Francisco is because of its amazing engineering. There's a mention of some artist. There's a mention of, I think the architect is there. No structural engineer. That's the reason why people don't know. We have so many amazing stories to tell. People are blown away when they find out the things that you do. Learn public speaking, get out there and talk to them. Just one of these things. Pick it up. Make friends, talk about your profession. There's so much they want to hear from you.
Yeah, I really enjoy the...
Okay, so that's it from my side. I hope you like this. If you're a professional working design engineer, then you know already what this person was talking about. We save a lot of life every day. We do this every day, every moment of time, whenever we construct a structure, whether it is building or bridges. But no one knows it. I hope at least you know what you are doing. You are not in the business of just earning the money. You are in the business of earning respect from the humanity for the work you are doing. Okay? So that's it from my side. Thank you very much for having such a patience for 1 hour, 10 minutes. Thank you very much. It's the end of session from my side. Thank you very much.
Vikram sir, we thank you so much for your precious time and knowledge. Looking forward to learn more from you and best of it.
Thank you.
Thank you, sir.
Thank you, sir.
And all the attendees, thank you so much for joining
Thank you,
with
madam.
us.
Thank you all.
Looking forward for more webinars and technical meeting with us.
Thank you,
Thank you.
Bikramji. Thank you very much.
Thank you, sir. Thank you.
Thank you so much, sir. Thank you.
Thank
Yes,
you.
Yes, everyone, thank you so much for attending and joining with us. Stay tuned to 𝗏𝗏𝗡. And